far sprinklers on the south block were barely clearing the next row over, and in the heat of a Tuesday afternoon, that meant the corn behind them wasn't getting water at all. Wendell Sasser stood at the edge of the field with a folded piece of paper in his hand, another estimate, another number he didn't want to look at twice. Beside him, Walt Sturgis, who'd been servicing irrigation systems in that county for the better part of 30 years, had his arms crossed and his eyes on the same weak arc of water Wendell was watching. "I think we're looking at another pump upgrade," Walt said. "Bigger unit, bigger motor, maybe a second well if this one's tapped out during peak hours." Wendell didn't answer right away. He'd already spent close to $38,000 trying to fix this exact field, and the idea of writing another check on top of that sat in his stomach like a stone. Off to the side, a young man in muddy boots and a faded ball cap stood near the pressure gauge mounted at the head of the main line, close enough to have heard the whole conversation. His name was Andre Whitfield, and he'd spent the last 2 summers on Sasser Farms moving pipe, swapping worn sprinkler heads, and doing whatever else the irrigation crew needed done. "Can I ask something?" Andre said. Both men turned. "Why does this same field hold good pressure at 5 in the morning?" Walt looked at him for a second, not annoyed, just weighing the question the way you weigh anything that doesn't quite fit what you already believe. "Because demand's lower then," Walt said. "Fewer zones running, cooler ground, less draw on the well. That's not unusual." Andre nodded and didn't argue. He wasn't there to argue. Not yet. The 3 of them stood there a moment longer, the pump droning steadily somewhere behind them, and the story of how Sasser Farms got to $38,000. And one more bad estimate had started almost 2 years earlier, at the beginning of a dry summer nobody had seen coming. Sasser Farms ran just under 900 acres out in the flat, sandy country of eastern North Carolina, sweet corn and vegetables mostly, with soybeans filling out the rotation on ground that didn't get irrigated at all. 220 of those acres depended on one deep well and one centrifugal pump feeding a main line that split off into 6 separate zones, each one controlled by its own valve, each one running sprinklers or travelers depending on the crop and the season. The south block, the farthest zone from the pump, had always needed a little extra attention. It was simple hydraulics. The farthest point in any system takes the biggest hit when something upstream isn't performing the way it should. For years, that had never been a real problem. The system held its numbers. The sprinklers threw a clean, even pattern, and Wendell hardly thought about the irrigation setup at all, beyond checking gauges out of habit. Then, in the first week of a particularly hot July, the south block started showing dry strips between sprinkler rows, thin bands of stressed corn that stood out clearly from the air and from the ground both. Wendell noticed it walking the field one evening, the leaves curling tighter than they should have this early in the heat, and when he checked the pressure gauge at the head of the main line the next afternoon, it was reading low, not alarmingly low, just low enough to explain weak throw at the far end of a long system. He called Walt Sturgis, who'd installed the original system a decade earlier and had serviced it ever since. Walt came out, ran the pump through its paces, and confirmed what Wendell already suspected. Discharge pressure at the pump head was fine at low demand, but once several zones were running together in the heat of the afternoon, it sagged noticeably, and the drop showed up worst at the south block, exactly where you'd expect a system running near its limit to show weakness first. "Pump's got some age on it," Walt said, "and that main line out to the south block was undersized when it went in, honestly, even back when it was new. You've grown this operation past what that pipe was really built for." It was a fair read. The pump was original to the system, going on 10 years old, and pumps do lose efficiency over time. Bearings wear, impellers erode slightly, seals get tired. The mainline diameter to the south block genuinely was on the small side for the acreage now being irrigated. Both of those things were true, and both were reasonable places to start. Walt recommended a larger pump with a bigger motor, and while they were at it, replacing about 400 feet of the undersized mainline section closest to the pump, where the friction losses would matter most. Wendell authorized the work. It came to just under $22,000 once the new pump, the electrical service upgrade the bigger motor required, and the mainline replacement were all added up. His wife had asked him plainly, sitting at the kitchen table with the invoice between them, whether he was sure this was the actual fix and not just the most obvious one. Wendell had told her, honestly, that Walt knew this system better than anyone alive, and if Walt said the pump and the line were the weak points, that was good enough for him. It was a reasonable thing to believe, and neither of them had any reason at the time to think otherwise. For a few weeks that August, it looked like money well spent. The south block held better pressure, the dry strips didn't reappear right away, and Wendell let himself believe the problem was behind him. By the following July, the same dry strips were back. The second season, Walt came at it from a different angle. He walked the sprinkler heads themselves, checking nozzle wear and spray pattern, and found several nozzles in the south block worn well past their service life, throwing a wider, thinner pattern than they should have, and losing effective pressure at the outer edge of their reach. That made sense too. Worn nozzles are a real and common cause of uneven coverage, and replacing them was cheap and easy relative to everything else, so they did that first, along with adding pressure-regulating heads at the far end of the line to help even out the flow across zones running at different distances from the pump. That cost a little under $6,000, and it helped, modestly, for about 3 weeks. When the dry strips came back a third time, Walt started looking harder at the well itself, wondering if drawdown during sustained peak demand was the real limiting factor, something the new pump simply couldn't fix if the well itself couldn't deliver enough volume once several zones pulled on it at once. He arranged a proper well recovery test, monitoring water level in the well casing while the pump ran under full load, and the results showed some drawdown, enough to raise a reasonable question about whether the well's yield was marginal for the farm's current irrigated acreage. That test alone, along with associated electrical diagnostics and a control panel repair when one of the zone relays started sticking intermittently during the process, ran close to another $10,000 by the time everything was billed out. None of it was wasted in the sense of being pointless. The pump really had been aging, the nozzles really had been worn, the relay really had been sticking. Every single repair addressed something that was in fact a little bit wrong with the system. But every single summer, once the heat set in and several zones ran together in the afternoon, the south block came up short on water, and by the time Wendell stood at the edge of that field for the third season in a row, looking at another proposed upgrade, the total already spent had crept up past $38,000. By that third summer, the strain of it had started showing in smaller ways too. Wendell's crew foreman had begun grumbling that every fix seemed to buy them 3 good weeks and then hand the problem right back. And a block of sweet corn on the far end of the south field had come in light enough at harvest the year before that the shortfall showed up plainly on the settlement sheet from the produce buyer. Corn that should have graded out at full ears was coming in tipped and underfilled on the rows nearest the property line, exactly where the sprinkler throw fell shortest in the afternoon. Wendell wasn't an angry man by nature, but standing in that field for a third season running, watching the same dry strips reappear in the same place, he'd started to wonder out loud, more than once, whether Walt actually had a handle on the problem, or whether they were both just guessing more expensively each time. Andre had been on the crew for most of that second and third season, mostly doing the physical work, moving pipe, replacing the nozzles Walt had identified, helping wire in the relay repair, none of it requiring him to understand the whole system, just his piece of it. But he paid attention the way some people naturally do, noticing not just what broke but when it broke, and it was during that third summer, helping check pressure readings across the zones on a punishing 96-degree afternoon, that something started to bother him. He'd been out at 5 that same morning, before his regular shift, helping a neighbor's crew with an unrelated job, and he'd walked past the Sasser pump house on his way, out of habit checking the gauge mounted near the road. It had read strong, full pressure, steady, nothing like the sagging numbers he'd see that same field produce 8 hours later in the heat. He mentioned it to Walt almost as an offhand comment, the kind of thing you say without expecting it to matter. Pressure was good out here, early this morning. Real good. Sure, Walt said. Less demand overnight. Cooler ground doesn't pull as hard either. Less transpiration, less draw on the whole system. It was a completely reasonable explanation, and Andre didn't push back on it. He just wrote it down anyway. in a small notebook he'd started carrying that summer for his agricultural systems class at the community college, more out of habit from schoolwork than any real plan to investigate anything. Pressure strong at 5 a.m., weak by 2:30 p.m. Walt says demand. Makes sense, but feels like more than that. The moment that actually sharpened his attention came about 2 weeks later, on another scorching afternoon when the South Block was clearly starving again. Wendell had come out frustrated, watching the weak arc of water barely reaching halfway across a bed of corn that badly needed it, and in irritation more than strategy, he told the crew to shut down 2 of the smaller zones that weren't in as urgent need, just to see if concentrating flow on the South Block would help. Andre was standing near the gauge when the second zone valve closed. The discharge pressure came back up almost immediately. Not over the course of minutes, the way you'd expect if the well genuinely needed time to recover its water level after being drawn down hard. It happened in what felt like 10 or 15 seconds, fast enough that Andre actually checked his watch out of surprise. He mentioned it to Walt again. That came back quick. Less demand, less draw, Walt said, already halfway back to his truck. Nothing mysterious about that. Andre didn't argue, but that night, working through a chapter on well hydraulics for his class, he read something that stuck with him. A well experiencing genuine drawdown under demand takes time to recover, sometimes minutes, sometimes longer depending on the aquifer, because water has to physically migrate back into the well bore from the surrounding formation. 10 or 15 seconds wasn't well recovery. That was something closing a lot faster than an aquifer refilling itself. He wrote that down too, and underlined it. A few days later, curious whether the pattern held on a day that wasn't quite as brutally hot, Andre checked the numbers again on a milder 88-degree afternoon. The same effect showed up, just smaller. Pressure sagged less, but it still sagged, and it still snapped back within seconds of a zone closing rather than recovering gradually. That told him the effect wasn't purely a function of heat and crop demand, the way Walt's explanation assumed. It scaled with how much total flow the system was asking for, hot day or not, which pointed even more clearly at something mechanical rather than something environmental. Andre's first real theory, once he let himself take the question seriously, was the intake screen at the well. It was the obvious suspect for anyone who understood the basics. A partially clogged screen would restrict inflow, get worse under high demand, and could plausibly explain uneven pressure between low demand and high demand periods. He asked Walt if they could pull and inspect it, and Walt, who by this point had grudgingly started to respect that the kid didn't ask questions just to hear himself talk, agreed. They pulled the screen on a Saturday morning. It had some buildup, mineral scale, and fine sediment, typical for a well that age, but nothing that looked severe enough to explain the magnitude of the pressure collapse they'd been chasing. They cleaned it thoroughly anyway, reinstalled it, and ran the system hard the following week under the same conditions that had failed before. The South Block sagged again, right on schedule, in the heat of the afternoon with multiple zones running. Clean screen. Same failure. Andre crossed the idea out in his notebook, noted how much time it had cost, and didn't let himself feel discouraged about it. A wrong idea, tested properly, still taught him something. It told him the restriction, whatever it was, wasn't happening at the well screen. That was when he started logging things properly, the way his instructor had shown the class to track a system instead of just reacting to it. Every day for 2 weeks, whenever he was on the property, he wrote down the time, how many zones were running, the discharge pressure at the pump head, and whenever he could get to it, the suction side reading too, the vacuum gauge mounted on the intake side of the pump that almost nobody ever looked at because it wasn't the number anybody cared about. That gauge told a story nobody had been reading. At 5 in the morning, with light demand, suction vacuum sat low and steady, right where the pump's rating chart said it should for the flow being pulled. By early afternoon, with several zones open and demand at its peak, that same suction vacuum climbed high, higher than Andre's textbook chart, suggested it should even at full rated flow for that pump. That was the piece that didn't fit. If the well itself were simply running short on water, the pump would show a symptom on the suction side too, but it would look like starvation from insufficient supply, a gradual, demand-matched rise in vacuum as more water was asked of a limited source. What Andre's numbers showed instead was a vacuum reading that spiked sharply and disproportionately once total flow crossed a certain threshold, as if something between the well and the pump itself were choking down harder than the well's actual yield should require. He brought his notebook to Walt. Walt's first reaction wasn't openness. It was mild irritation, worn thin by 2 full seasons of chasing this same problem himself and coming up short every time he thought he'd finally solved it. "I've got a farm foreman asking me why he's paying me every summer for the same field," Walt said, not unkindly, but plainly. "I don't have time to chase a theory that doesn't hold up. What I need is something I can act on." "I know," Andre said. "That's why I logged it for 2 weeks instead of bringing you 1 reading." Wendell's crew foreman, a wiry man named Otis who'd worked the farm longer than Andre had been alive, had told Andre flat out a few days earlier not to go bothering Walt with theories while there was pipe to move and heads to swap before the next irrigation cycle. Andre had done both anyway, logging his readings early in the morning and late in the evening on his own time, careful not to let the notebook interfere with the work he was actually being paid to do. Walt looked over 2 weeks of numbers with the kind of patience a man develops after 3 decades of being occasionally humbling wrong. "You're telling me suction vacuum is spiking faster than discharge is dropping?" "Every high-demand reading, yeah, and it's way past what the pump curve says it should be for this flow rate, even worst case. Could be the well really is marginal at that volume. That's still possible." "It's possible," Andre said, "but if the well just couldn't keep up, I'd expect the vacuum to climb steady with demand, matching it. This isn't matching it. It jumps once you cross a certain number of zones open, like something's choking harder than the well should be choking on its own." Walt sat with that for a moment, arms crossed, looking at the numbers instead of at Andre, which Andre had come to understand was usually a good sign. "And when we close a zone, pressure comes back in 10-15 seconds. Every time. That's too fast for the well to be the limiting factor recovering." "You're right about that much, at least on paper. I think whatever's restricting flow is somewhere between the well and the pump. Not the pump itself, not the well itself, something in between." Walt looked at the layout diagram tacked to the pump house wall, the one showing the well, the foot valve at the base of the suction line, the suction piping running up to the pump, and the check valve just ahead of the pump inlet that kept water from draining back down the casing when the system shut off. "If you're right," Walt said slowly, "the pump's been starving from the wrong side this whole time, and a bigger pump was never going to fix that." The test Andre proposed was straightforward in concept, though Walt insisted on doing it properly rather than rigging something makeshift. They installed a second pressure test port on the suction line, downstream of the suspect check valve, but still ahead of the pump inlet, so they could compare the vacuum reading on either side of that valve at the same moment, under both low and high demand. If the valve were passing flow cleanly, the readings on both sides should stay close together no matter how much demand was placed on the system. If the valve were restricting flow, the difference between the 2 readings should widen as demand increased, worse the harder the system was pushed. Their first attempt gave them a confusing result. Both readings climbed together under high demand, which didn't match Andre's theory at all, and for a moment he felt the same sinking feeling he'd had after the intake screen came back clean. Walt caught the problem before Andre did. The second test port, tapped in a hurry, had ended up on the same side of the valve as the first one, close enough to the valve body that a casting boss in the fitting had put both gauges effectively upstream of the true valve seat instead of on opposite sides of it, the way the diagram suggested. "Diagrams tell you where things are supposed to be," Walt said, moving the second port to a cleaner location further downstream. "The pipe tells you where they actually are. Always trust the pipe. It cost them the better part of an hour, draining the line again, relocating the port, waiting for the system to settle back to a proper baseline before trying again." Andre apologized for the wasted time, but Walt waved it off. "You didn't waste it," Walt said. "You found out the port was in the wrong spot before we built a conclusion on top of it. That's the whole job. Better to lose an hour here than trust a bad number all the way to a repair invoice." They reset, ran a proper cold baseline early the next morning with light demand, and got clean matching numbers on both sides of the valve, exactly what a healthy system should show. Then they waited for the heat of the afternoon and opened every zone the farm would normally run together during peak demand. At full load, the reading just ahead of the valve held close to the pump's rated curve. The reading just past the valve, closer to the pump inlet, showed a vacuum sharply higher than it should have, a real and measurable pressure differential across a valve that was supposedly wide open the entire time. Walt stared at the two numbers for a long moment. "Show me that reading again." They ran it again. Same result, same gap, same pattern repeating exactly with the same zones open. "If that holds under one more run," Walt said, "we're pulling that valve." The valve in question was a swing check valve mounted in the suction line between the well casing and the pump, installed to keep the line primed by preventing water from draining back down into the well whenever the pump shut off. From the outside, there was nothing to suggest anything was wrong. The valve body showed no visible damage, no leaks, no external sign of wear, and the manual isolation valve just ahead of it, the one with the handle a person could actually turn, sat fully open the way it always had. Walt shut the system down, drained the section, and pulled the check valve off the line for inspection on the bench, with Andre helping loosen the last stubborn bolt. At rest on the bench, the internal disc swung freely and appeared to open fully when pushed by hand, which was exactly why nobody had suspected it before. A quick visual check, even a careful one, would have shown a valve that looked like it was doing its job. But Walt noticed the hinge pin had a slight roughness to its motion when he worked it slowly, a stiffness that hadn't been there when the valve was new, likely from years of mineral buildup working its way into the hinge mechanism a little at a time. Under low flow, that stiffness didn't matter much. The gentle push of water at low demand was still enough to swing the disc most of the way open, enough to pass the modest volume the system needed in the early morning or late evening. Under high flow, with several zones open and the pump pulling hard, the same stiff hinge meant the disc couldn't swing to its full open position fast enough or far enough against the increased flow trying to push it. It hung back, partially restricting the passage exactly at the moment the system needed it open the most. "It's been doing this a while," Walt said, working the hinge back and forth and feeling the drag in it himself now that he knew to look for it. "Not enough to notice it idle, enough to choke you the second you really lean on it." That was the piece that explained everything. Mornings looked fine because demand was light enough that even a sluggish valve could pass what was needed. Afternoons collapsed because peak demand needed the valve to swing fully open, and it wouldn't. Closing a zone brought pressure back in seconds because it wasn't the well recovering at all, it was simply less flow being asked to pass through the same partial restriction, and no pump, however large, was ever going to fix a bottleneck sitting upstream of it on the suction side. The south block wasn't short on water because the well was weak or the pump was too small, Walt said, mostly to himself, still holding the disc open and closed by hand to feel the stiffness for himself. It was short on water because something ahead of the pump wasn't letting enough through when it mattered most. Andre didn't say much back. He'd already written something close to that same sentence in his notebook the week before, sitting at his kitchen table after the first suction vacuum readings started making sense. They ordered a replacement check valve, a straightforward swing-type unit rated for the line size, along with new gaskets for the flanges on either side. The valve itself ran around $210, with fittings and a few hours of labor to pull the old one, install the new one, and reprime the line, bringing the total repair to a little under $600. Walt called Wendell that evening. "I need you to hold off on that new pump quote," Walt said. "We found something upstream. It's not the pump, and it was never the well either." Wendell's voice on the other end had the flat, tired sound of a man who'd heard promising theories before and watched them fail to hold up. "What is it?" "A check valve. Suction side. It's been sticking just enough to choke you at peak demand this whole time." When Wendell came out to see it for himself, Walt laid the old valve on a piece of cardboard on the tailgate and worked the hinge by hand so Wendell could feel the stiffness. "Handle out front's been sitting fully open the whole time," Walt said. "Nobody had a reason to look at this thing. It's not the kind of part that shows up on anybody's suspect list, because from every angle that mattered, it looked like it was doing its job." Wendell turned the little disc back and forth himself, feeling the drag Walt was talking about. then looked out at the south block, quiet in the afternoon heat with the pump shut down for the repair. Andre caught this? Andre logged 2 weeks of suction numbers most people never bother reading in the first place. Noticed a recovery time that didn't match anything physically possible from the well, and pushed for a test that isolated exactly where the restriction was sitting. I'll be straight with you, Wendell. I'd have sold you another pump upgrade if he hadn't kept pushing on this. Wendell looked over at Andre, who was coiling a hose a few feet away, trying not to look like he was listening to every word. You're the one that asked about 5 in the morning. Yes, sir. I remember thinking that was a strange thing to ask. It bothered me for a while before I understood why. Wendell didn't say much else right then. He just nodded slowly. The particular nod of a man doing arithmetic in his head, $38,000 already spent. Another $12,000 to $20,000 narrowly avoided. All of it turning on a valve that cost $210 and a hinge pin nobody had thought to check. He asked Walt one more question before he left. How long would that valve have kept getting worse if nobody caught it? Walt turned the disc over in his hand, feeling the drag in the hinge one more time. Hard to say for certain. Mineral buildup like that doesn't move in a straight line. Could have held steady another 2 seasons. Could have seized up worse by next July and choked you down even at low demand. Either way, it wasn't fixing itself, and it wasn't ever going to show up on a pump curve or a well test, because neither one of those tools is built to look at a suction valve nobody suspects. They reassembled the line, reprimed the pump, and ran a full test before calling it finished, because a repair wasn't proven until it held up under the exact condition that had exposed the problem in the first place. They waited for a genuinely hot afternoon, opened every zone the farm would normally run together at peak, and watched both gauges, the one just ahead of the new valve and the one just behind it. The 2 readings tracked close together the entire time, no widening gap, no spike, exactly what a healthy suction line should look like under full demand. Discharge pressure at the pump head held steady too, none of the sag that used to show up right on schedule once the heat and the zone count both climbed. Out at the south block, the sprinklers Andre had watched barely clear the next row all summer now threw a clean overlapping pattern across the beds, water-reaching corn that had been going thirsty in that same spot for 2 full seasons. Wendell didn't run the test just once and call it settled. He had the crew keep the same zone configuration running for the rest of that afternoon into the hottest stretch between 2 and 4, the exact window that had failed every single time before. The pressure held the whole way through. Out at the edge of the field, Otis walked the rows himself that evening. The same foreman who'd told Andre a few weeks earlier to leave the theorizing to Walt and stick to moving pipe. He didn't say much when he saw the corn getting even coverage all the way to the property line for the first time in 3 seasons, just stood there a minute, then told Andre it was good work, plain as that, and went back to closing up for the night. Wendell didn't push forward with the pump and well upgrade Walt had originally quoted, which would have run somewhere between $12,000 and $20,000, depending on whether a second well ended up being necessary. He didn't describe it to his neighbors as money saved, because the $38,000 already spent was still spent, every dollar of it, on repairs that had each addressed something genuinely a little bit wrong with the system, even if none of them had touched the actual cause. What he told people instead, standing at the edge of a field or leaning against a truck bed the way farmers do, was that the whole problem had come down to one valve nobody had ever had a reason to suspect, and a kid on the crew who cared enough to write down what time the gauge read what it read. A few weeks later, Walt had Andre out for a routine pressure check on an unrelated part of the system, a different farm 2 properties over where a customer had reported a minor imbalance between 2 zones. "Bring your notebook," Walt said, tossing him the keys to the service truck. "We're pressure testing the whole layout before we touch anything. I want times, I want suction and discharge both, same as you did out at Sasser's." Andre climbed in, notebook already in his back pocket where it always was, now, and as they pulled out of the yard, Walt glanced over at him. "You still taking those ag systems classes?" 2 more semesters. Good. Man who reads a suction gauge nobody else is watching is worth having around. Out at Sasser Farms, the south block kept running through the rest of that summer and into the next, Pressure holding steady no matter how many zones opened together in the worst of the afternoon heat, and nobody watching those sprinklers throw a clean, even line across the corn would ever guess how close the whole system had come to another $20,000, spent chasing a problem that had never been the pump at all. Wendell had the crew keep a simple log after that, nothing fancy. Just suction and discharge readings recorded twice a week no matter how the system was running, a habit borrowed straight from the notebook Andre had been carrying all along. It cost nothing but a few minutes a week, and it meant that if anything upstream ever started drifting again, quietly, the way that valve had drifted for years without anyone noticing, there would be numbers on paper to catch it long before it cost the farm another season and another estimate nobody wanted to open.